In this example, we are given that a small metal plate is placed normally at a distance 2 meters from a point source of light, and a photocurrent of 18 milliampere is measured from the metal plate. And it is saying if the plate is shifted away from the source at a distance of 6 meters, we are going to find a new photocurrent. Now, in this situation, we are given that if this is the metal plate, from the metal plate at some distance, say x, if a point source of light is placed, then we know that from the plate here, photocurrent will be directly proportional to the number of photons incident onto the plate per second, which will certainly be proportional to the intensity of light. And if there is a point source having a power P, here we can say at a distance x due to a point source, intensity is given as P by 4 pi x square that we already studied in the previous section. And in previous sections we have studied as for a point source, intensity is inversely proportional to x square. Here we can directly write the photocurrent will also be inversely proportional to the square of the distance. So here we can say if I is the photocurrent in the two situations, we name it I1 and I2, here we can write I1 by I2 will be equals to x2 square by x1 square. So this implies we are getting in the second state, photocurrent will be equals to initial photocurrent multiplied by x1 square by x2 square. So here initial photocurrent we are given with 18 milliampere and the distances are initially it was 2 and finally it is 6. So here we can write it 18 multiplied by 2 by 6 whole square milliampere. If you simplify, this will be 4 by 2, this will be 2 milliampere, that will be the answer to this problem.